Okay, so we need some more practice plotting these piecewise functions. So let's do 2 more examples. This is part 3. Example 3. This time our piecewise function f of x is equal to, we still have 2 pieces. We have x cubed, and that's if x is less than 2, and we have a -1, and that is if 2 is less than or equal to x is less than 5. Oops, it's less than 5. Okay, so when we look at this one, again, we notice we have a left side and we have a right side. Our boundary number between the 2 pieces, so Bn for boundary number, is at 2. And I need to notice that the graph is going to stop over there on the right side at 5. So I need to think about that when I'm building my tables. Okay, well, what do these 2 sides look like? Well, the left side is a curve. That's x cubed. That's that S shape, we call it, something like that. The right side is -1. That's a constant. So net constant is a horizontal line. So no, we're going to have a horizontal line. And again, this just helps me keep track of what I'm trying to do. So let's go plot some points. So on our left side, and notice how much labeling I'm doing. That's just going to keep everything on track with what we need. So we have y equal x cubed. The very first number I'm going to plug in is my boundary number, which is 2. And because the inequality is telling me it's less than 2, we'll call that an open circle. So I need to make sure it's open when I go graph it. Okay, well, 2 cubed is 8. Now I need other numbers to get this curve to look like it needs to look. So I'm going to make sure that I pick numbers that are less than 2, so to the left of 2. So we'll use 1. 1 cubed is 1. 0 is a good number to use. 0 cubed is 0. -1. -1 cubed is -1. And finally, -2 gives me 8. So notice I'm plotting quite a few. It's because it's a curve. And I want to make sure I get the curvature in the correct spot. So I can go graph those points. So we have 2, 1, 2, 3, 4, 5, 6, 7, 8. Oops, sorry, open circle. Make sure it's an open circle. That's why I write that note to myself, is to remind myself that it's an open circle. We have 1, 1, 0, 0, -1, -1, and then -2, we're down at -8, 2, 3, 4, 5, 6, 7. It looks something like that. Just like we said it should. That's our S shape. Okay, what about the right side? So the right side is just y equal to -1. So that is a horizontal line at -1. Now, I want to make sure everything is working in your brain. So what we're saying is that if we plug in our boundary number at 2, it's a closed because of the inequality statement. The output's -1. This one, though, is going to stop at 5. It's not going to go beyond 5. If I plug in 5, it's going to be open. And it's open because of the inequality statement. You again get a -1. So that's saying that over here at 2, we're down here at -1 with a closed circle. 3, 4, 5. And at 5, we have an open circle. We just have a little horizontal line, and that's it. It stops. That's the end of our function. So there's our graph. Now let's find our information. So the domain starts on the left side of the arrow over here, and the inequality is telling you it's starting at -infinity. And it's stopping at 5. And that's an open circle because it doesn't go beyond that 5. So we're going to use a parenthesis. Our range is the bottom of the graph. Well, down here is the bottom. That's -infinity. The top of our graph is up here at 8. But again, it's an open circle, so we use a parenthesis. This open circle is covered because it's already exists as a value on our function at -1. The intercepts are at the origin, both of them, the x and y. It's still not continuous. You cannot trace it without lifting your marker or pencil. And there's your second piecewise function. Nice job. Hopefully it got a little easier, right? Because you've got a little more practice. Let's do one more. So example 4, we have f of x is equal to -x minus 3, and that's if x is less than -3. I also have 9 minus x squared, and that's if -3 is less than or equal to x is less than 2. And we also have a 4, and that's if x is greater than. So 3 pieces this time. So I have a left side, middle, and I have a right side. And I have 2 different boundary numbers. So my boundary numbers are x equal to -3. That's the break between the first 2 pieces. And a 2, which is the break between the middle and the right side. So in terms of analyzing them, well, what do we know? Well, we know that first one is going to be a line because it's a linear equation. That's got a first degree on it. So it's a line. It does have a negative slope. So my line's going to go downhill this time. The second piece, the middle piece, has got that x squared on it. So that's that parabola, that U shape. However, I'm going to note to myself that because there's a negative out front, that does some funky things to it, which are in the next section. But for right now, we know it's a parabola and it's actually going to open down. We'll talk more about that in the next section. And finally, we have another horizontal line here. So, okay, so there's our analysis. When we're all done, we should be mashing these pieces together. So let's start off with the left side. That's that y equal -x minus 1. Again, when I build my table, first thing I'm going to do is use its boundary number, which is -3. And it is open. Squeeze it in there. So -3. So the opposite of -3 is a +3. -1 gives me a 2. I need another number just to get a nice picture. So to the left of -3, we're going to use -4. So the opposite of a -4 is a +4. -1 is going to be. So there's our first piece. So we have -3, +2, and that was open. And we also have -4, +3. And again, when I draw it in, I'm going to go to the left. There it is. Yay! Just exactly what we said it was. Okay, the middle. It's y equal minus x squared. This is the one where I have to plug in both of the boundaries. So we're going to plug it in -3. It's going to be closed because of the equal to. And then I'm immediately going to plug in the 2, the other end of that piece, recognizing that it's open. So I accounted for both of my boundary numbers on that middle piece. -3, so 9 minus -3 squared is +9. 9 minus 9 is 0. That was nice. If we plug in a 2, 9 minus 4 gives us 5. Now I need a few more points than that. So I'm going to go ahead and plug in 0. I'll get a 9. I'm going to use a +1 and a -1. So I plug in a +1, I get 8. If I plug in a -1, I also get 8. And that should be sufficient to give me my U shape that I'm expecting. So at -3, we're over there at 0. -3, we're at 0. And it's closed. At 2, we have 5. So we're at 2, we're up at 5. 1, 2, 3, 5. And that's open. So make sure I'm paying attention to my open and my closed. At 0, we're up at 9. 5, 6, 7, 8, 9. At 1, we're up at 8, and at -1. So it looks something like that. Okay. Now what? Well, now we got our right side to do. So right, we have y, and again, that's a horizontal line. So it's a horizontal line 4. We're going to make, again, you don't really need this, but just to complete, I guess, the analysis of it. The boundary number here is 2. It is closed. If we plug in a 2, we're going to get a 4. If we plug in any other value bigger than 2, we'll also get a 4. Whew, that was hard to say. So up at 2, 1, 2, 3, 4, we have a closed circle, and then it's a horizontal. So the picture looks something like that. Isn't that an interesting looking picture, right? Okay, well, let's find our domain. Well, it's got a left side as an arrow and a right side as an arrow. It's going to go from -2 to -2. Now the range is kind of sneaky because the bottom of the graph is easy to get out at 0 with a bracket. But where's the top of the graph? Well, the top of the graph looks like it's here, but the arrow on this side is going to keep going up. So it's actually going off towards infinity. It does have intercepts. So it's got an intercept over here at -3, 0, and another intercept up there at 0, 9. So x-intercept, y-intercept. It's still not continuous. So none of the pictures I picked or graphs are continuous. wraps up part 3. Then the next thing we need to do is actually go backwards. So that's our next task.